So everyone knows what I look like. That's me, an older, probably more stressed out, grey haired version of what you can see on the screen, but I will keep my video off for the presentation. And we might get underway. So thanks everyone for attending. My name's Doug Vincent. I'm one of the co-founders of Mastt. And today's webinar is on prediction of capital work success using machine learning. And I'm super pumped to be back in the office after a long lockdown. So it's nice to get back out, and hopefully we can actually deliver some more presentations like this in person. So just before we do get started, everyone's muted, but I certainly welcome any questions during the webinar. So please use the question box or raise your hand on Zoom, and I'll do my best to get to it at the end. And I'm always really interested to speak with like-minded individuals on the industry. So if you wanted to reach out with me, I'll provide my email at the end, and we can connect. And there will be a recorded or a link to the recorded session shot around to everyone. So don't worry too much about taking notes throughout the session. And this is actually the fourth webinar, the last webinar in a series that we ran on project management in action. So the first webinar was all about risk. So how does Mastt get project managers out of boring old spreadsheet risk registers and into a data-driven system? And then we did the same thing for cost. How do we get out of cost spreadsheets? Can you guys hear me? Let me go back. Hey guys, can everyone hear me? Yes? Okay, cool. Sorry, I said someone from the chat there said that they couldn't hear me. I'll keep going. All right, there's the younger self again. And so I was just recapping where we're up to in the series. So the second webinar was all about cost management, getting project managers off spreadsheets for cost. And then the third, reporting. How do we take risk, cost, and other data and then provide really neat real-time reports? So today is all about how do we take all of that great data we've got and then apply machine learning techniques to our industry. And it's been a bit of a journey. So you could almost think of it like, if I use Lego as an analogy, that we've picked up all of the Lego blocks like in all of the spreadsheets, and we've arranged them really neatly into a system. And then with that system, we can fetch data and present it in any way that our customers and key decision makers like. And then the final arrangement that we're looking at today is what insights can the data offer us to determine new paths forward for a project or prevent and mitigate risks. And then we're going to do another series entirely on data insights out of Mastt and out of the industry, which will probably be another 4-part series. But just a little bit about Mastt. So for those of you who don't know us, our mission is to digitize the construction industry. It's a big task, but we're very focused on working with PM consultants and asset owners with respect to capital project, program, and portfolio management. And in a past life, several years ago, I was a project manager. And when I joined the industry out of university, I got a really rude shock to find everyone managing their capital works portfolios with spreadsheets. And these were not, small projects. These were huge hospitals or naval wharves, and there's sometimes hundreds of spreadsheets on just one project. And all of it is just, trapped in people's local drives. And so it's no wonder to me that you see cost and time blowouts happening all the time. And it wasn't just one sector. This was like the government, the state government, the education, real estate sector, health, mining, oil and gas. Everyone was using these spreadsheets to track all of this really important information. And it's all siloed and all then being fed into PowerPoint and Word reports. So every project would always start the same way and became this really repetitive process for me. And you've got dozens of really valuable information in all of these disparate systems. So I went along with this for many, many years. You've got your cost tracker, you've got your schedule tracker, and you've got your risk register, and then your right-click copy, right-click paste into various Word documents monthly. And I'm thinking to myself, gee, there's a real huge, vast amount of information here that's all trapped in all of these reports. There's got to be a better way to use that data, because it is really valuable, and really valuable lessons will come out of it. And we're going to take a look at how we can unlock some of that. But the real sticking point is when you start to think about the data that's trapped in a time series. So it's all built up over time. And this is even more inaccessible than just having different silos for your cost, risk, and schedule trackers. And so what this means is that we have large quantities of this raw data spread out over time, making discovery-orientated analytics and practices like data exploration and data mining and statistics, and certainly machine learning, nearly impossible. And then the ever-changing format of the spreadsheets, Joe Blow adds another column over here, and then he changes his formula over here, and then he adds a row, means that all of it is not standardized. And so this is not a good situation as these spreadsheets build up over to today. This is not a good situation for machine learning. It actually makes it impossible to do. And so before we dive into it, I'm just going to explain with a really simple example, and this is a great example, I love using it, on what is machine learning. So we're going to start with two computers. We're going to call one computer the learner, and we're going to call the other computer the answer. And we're going to give the learner just a randomly generated pixel screen. And so the learner produces this, just totally random pixels. And then we're going to give the answer the Homer Simpson face, probably one of the most recognizable faces in the world. And then what is going to happen is the learner is going to be the one that we're going to train. So that's the one that's going to learn, and it's going to randomly regenerate those pixels, and it's going to send it to the answer and say, does this randomly regenerated pixel screen look closer to a Homer Simpson face? And then the answer is going to say yes or no. And this is going to happen millions of times every second. And then over time, what happens is it starts to get closer and closer and closer to the Simpson's face as it starts to randomly regenerate the pixels, send it to the answer. Does this look like Homer Simpson? Yes. And it gets better and better and better to the point that it can actually reproduce a Homer Simpson's face. And this is a really old example. I mean, this stuff is getting really, really good. And then here's a few examples of the progression of this type of technology over time. But I'm sure some of us have seen on social media the Tom Cruise videos or those other deep fake videos where it's indistinguishable to the person. Like, that's how good some of these AI techniques are at putting together an entire person's face. And so we're not going to regenerate a Homer Simpson face, but we are going to try to make our own Homer Simpson face, but the face is going to be a picture of the future of capital projects. But to start doing this, we need to really, effectively gather, store, and manage data for projects starting today. And this data preparation piece is probably the most important step in it, and that's where all of the effort is. Writing the actual algorithms these days is fairly straightforward, and there's like off-the-shelf tools that you can buy and use for free, and I'll list them out at the end. So there's these tools for free that you can actually experiment on this stuff yourself. And so the first thing is all about establishing, a data framework and a data collection mechanism. And so if you picture, we take these cost spreadsheets, schedule sheets, risk sheets, and we need to get them into a database. So we've got cost database, schedule database, risk database, and these databases are interlinked and they're all hosted on the cloud. So we use Microsoft Azure as a big partner, but there's also AWS, Google have a cloud as well. So it's all pretty similar stuff. But now in what we call a common data environment, this information in time series is all accessible to us. So data on all the costs, all the schedules, locations, project types, it's all in there, and we can fetch it really quickly and really easily. And what's the data collection mechanism? Well, that's Mastt. That's why we built it. That's how we get the data into that common data environment. so that we can start using this data for the benefit of the owners and for the benefit of these businesses delivering projects. And we're going to take a look at a couple of examples today on how we can use machine learning and the power of the data that we have to generate some initial insights. And so we'll look at a basic one first. So example one is all about power search and character recognition. And then example two is our anomaly detector, on scheduled data, which is really cool. And then the third example is the scenario predictor, which is how we predict the future, build that Homer Simpson face, but for a capital project. So let's dive into example one, power search and character recognition. And so what is it and why use search? Well, because we can train a computer to build a Homer Simpson's face. We can also train it to understand words. And so the method that we use is called semantic search. And this is a data searching technique in which a query aims not only to find keywords, but to determine the intent and the meaning of the word that a person is using. And so in a layman's terms, it's trying to understand the natural language the way that a human would. And so say if you're talking about in an email talking about a claim, here in Australia, that would probably mean a payment claim or an invoice. So that's the type of association that we're trying to make. And so with Mastt, we are trying to understand that natural construction terminology so that we can think like a project manager. And why is it cool? Well, it enhances the quality of the search results. It improves the experience of the users, and it certainly strengthens the way they can perform their role. And it also allows us to tag activities with different search terms and different words to build a higher quality data environment. So let's take a quick demo of how it looks. And I'm just going to cut over to the environment. And this has been built with our partners at Relevance AI. And we've got just mock data loaded up in here to give you an idea of how it works. So say I'm searching for an airport, I misspell it, I search airport, and it still gives me the results of the projects we need. Flight Terminal A project, we've got the aircraft hangar project, and I can add the R and it'll still come back with the results. Or say I search for harbour. What projects have we got around that theme? Oh, we've got a wharf extension. And so the AI understands the word harbour, understands the intent of what I'm searching for, and gives me the results accordingly. So that's an example of ML in search. But how can we use this understanding of natural language in the construction industry? Here we go, going forward. Sorry. So how can we use this intelligence we have on what words and characters mean in the industry in other ways? So one example is payment claims. So at Mastt, we automatically produce payment claims out of our system. PDF, that's an example of a payment schedule produced automatically out of Mastt. And this is all mapped into our common data environment. But say you receive a payment claim from an architect or a builder and it needs uploading into Mastt. So we can use our search and character recognition to do that automatically. And that's called OCR, or optical character recognition. And so this is a new tool that we've developed, probably be released mid next year, where you can just drag the claim onto the system and it recognizes every field that's on there. It knows the terminology, it understands the meaning behind the words on the payment claim. And so it doesn't have to be the same format or template. It can be different every time and it understands what it means. And so with this type of technology, the PM doesn't have to add in any data at all. It just drags the claim onto the system and Mastt uploads it, and it already checks all of the compliance, such as, has this variation already been claimed before? And it throws up an error. And so this is one really powerful example of how machine learning in our industry can save time and automate mundane manual tasks. So that's example one, fairly basic, but let's move on to a more advanced example with anomaly detection of the scheduled data. And at Mastt, we don't replace Microsoft Project or Microsoft Primavera, we manage a project lifecycle and stage gates for the entire project, which gets every project in the portfolio running on the same drumbeat, and then we roll those schedules up. But working in a common data environment with Mastt means that we have these large quantities of raw data that are spread out over time, making discovery, mining, and statistics really easily. So this affords us the opportunity to identify patterns, trends, and relationships across multiple project schedules, which we can then learn from. So that's example of one project. Say we then have 4 projects and we roll them all up. We've got a database of planned baseline and actual dates, and we know the time between milestone 1 and milestone 2 is X days, and then from milestone 2 to milestone 3 is X days. And that gives us a benchmark on how long it should take a project to progress through the life cycle. And then using machine learning, we can understand, and with real accuracy, what that time should be and how frequently the user is updating that information. And so why is this cool? Well, it standardizes the project drumbeat, captures all of this really important information that we need for learning, and then we can benchmark this against projects in real time, so that we can stop risks and issues before they occur. And it also informs future project planning. Everyone always says, oh, here's a schedule, it's going to be done in 18 months. Well, is that really the case based on past project data? Well, at the moment, it's very hard to know. It's all trapped in spreadsheets. So let's take another look. Cut over to the demo environment. I'm just going to show you really quickly the Mastt project dashboard. So I'm going to scroll down. Here's an example of the schedule. So all the milestones through each phase, baseline date, start dates, right through to the end. And then imagine we take this project A, and I'm going to dart across to the next tab, and we combine that project A with 4 other projects. And now we can see all the milestones on the page, all in one spot. And so this is an example of how we roll up the schedule. And then with our anomaly detector, we can then have a view of all of that information in one spot. So imagine across all of these all of these project schedules, we're understanding the patterns, understanding the relationships between dates, and then that gives us a view over time based on the milestone the project is up to, how that project should look, and then put brackets around that time for those timeframes. So this gives us a swim lane of what we know a successful project to be. And then we run the live portfolio across those swim lanes. And when it steps outside the range of the swim lane, we know that's a leading indicator of a risk or an issue, and it throws up what's called an anomaly. And then that at least brings to the attention of the program or the portfolio manager that, gee, project B has got its construction commencement date starting, within 10 days of the last milestone. And based on every other project that we've done, that is basically impossible to happen. And so that flags the risk, so the portfolio manager can then make a change in that project schedule and address that issue with the project manager. And this all runs in real time. So based on all the activities that a project manager is undertaking day to day, feeding all of that project schedule data up into the anomaly detector. So this is like an MVP version of it, and really powerful tool. This will be out for all of our customers next year. All right, so let's move on. All right, example 3, making good time. So this is a scenario predictor, really cool tool. This is all about predicting project outcomes, specifically around cash flow and spend. And we've made some fairly remarkable discoveries about forecasting cash flow while developing this technology that's not entirely ready for the market yet, but we wanted to share what we've learned and how we're approaching it a little differently. And essentially, this is using a similar thing of past project data to identify those patterns, trends, and relationships, but then use the trend to make a prediction. And this takes in schedule data, risk data, and financial data that we have. But how do we actually, cook this cake? Well, we need the common data environment, but then we also need a data scientist. We've got one of those creatures. His name is Dom. And DOM is the one that puts together all of the algorithms that the machine uses to then predict the outcome of those projects. So what does it actually look like? I mean, it's always interesting just to actually see. I mean, this is an example of how it looks. This is not our actual code, but that's actually, what it all looks like. And to a lay person like me, I'm not a software engineer. That is just gibberish on a page. So I've got a simpler example for us all here to see. And you can think of it like correlating data, but lots of it, and then spotting a trend in it like you have on a scatter plot, and then using that trend to stretch it out over time. So on the left, we've got 3 use cases, and this is some real data as well. And we start to correlate this information and then predict the future in a similar way to what you saw on the scenario, the anomaly detector for schedule earlier. And then you can make these trends and shoot them out into the future, and then compare that with what the project manager has done to identify overspending, underspending, or suggest, perhaps more optimal allocation of capital. And then we can actually use all of this information across thousands of projects that we've captured within the system to get more and more and more accurate on predicting those project spends. So I'll cut across to another demo and I'll show you how this looks, or how at least we are thinking about it. And so we call it a scenario predictor because it's machine learning based, but you can run any scenario you want. So say you wanted to, it was the beginning of COVID, you had all of your projects running, and we can see some of them down the bottom here, again, all with mock data. And then we've got the cash flow here, actuals historically, and forward we have the prediction. So this is cash flow within the financial year, and then we have the cumulative view of that on the right. And so say you wanted to run a prediction scenario based on these 3 projects, or maybe you want to stop a milestone or delay a milestone, take project B out, leave project B in. You can then run a scenario, get that cash flow prediction with accuracy, generate a report, and then run off to a meeting and say, hey, I've ran 10 scenarios. Here's the predicted outcome across all of these projects in this scenario A, scenario B, scenario C. And that's the type of fast level of fidelity decision-making that we want to be able to provide our customers with the system. All right, so we'll move on to a quick benefits recap. And I like to do the project program portfolio recap. And certainly down the bottom, I always empathize with the project managers who these days, are no longer struggling in spreadsheets. They're producing really great reports for their project directors and program managers, and they've got more time to give back and focus on the project. And also, these are a younger generation that are used to using software, so the morale is boosted and they're feeling good. And then at that program level, we're now finally able to see across projects, across the program, those interdependencies, and make comparisons across and benchmarks across projects, and ultimately prevent those cost and time blowouts before they occur. And then at the portfolio level, we're establishing this amazing lessons learned framework through data. So that's one of the most important things from setting this up. It's all about lessons learned, carrying that forward. We're also getting greater governance and control, which actually boosts the ESG score of the organization. And this is on top of all of that real-time visibility. So the future is bright. Well, it's getting brighter anyway for construction technology. So back to my original example, we've picked up the Lego pieces, arranged them neatly into a system. With that system, we're fetching it to produce great reports. I've shown you today how some of these insights are able to drive decision-making and further automation of work. But there is a whole lot of other stuff coming with respect to applying all of these together in robotics and other types of data science applications. And I'm sure some of you have seen Boston Dynamics dog walking around the construction sites. There's principles out of the self-driving cars that can identify objects on the construction sites, BIM models, QR code scanning on site for materials tracking. And then last year, I remember I got a bit of a view at a digger, an excavator that was robot driven. And it's funny, you see this thing driving around the site with no person in it. Really, really, really cool. So there is a bright future there. And how can you get involved in that? So you can plan, get off spreadsheets and documents, can engage. There's a huge construction tech scene these days in Australia and overseas that you can get involved with. Universities have also got really awesome partner programs. So we work at UNSW and University of Sydney with their capstone projects. And there's a bunch of incubators and startups which would just be dying to give free trials to people on the amazing technology that they're working on. And I can provide names if you need to. It's also great to join and participate, like today, webinars, newsletters. There's great influencers out there, and hopefully from next year anyway, there'll be all these summits, back in person as the world returns to normal. And then experiment. So these are just the free tools that you can get: TensorFlow, Automation Anywhere, and AWS. And they're similar to spreadsheet based. So you can paste data in there as if it was in a spreadsheet and then start to generate insights. But it's good to start small, low cost trials. And I always like to end on a quote. And this is from a customer, WSP, very large engineering firm. And Fergus, who's at the PM over there, said that I have the feeling that after making the change to Mastt, I will never go back to how I run projects at the moment. And he never has since then. So that's all for today. And if anyone would like a bit more of a demonstration into what you've seen, or maybe you just want to reach out to me and have a chat, I've got my email on here. And I'd really welcome any feedback from today as well. So if there are any questions, happy to receive them in the chat, or I look forward to receiving an email and catching up with you another time. So many thanks for today, and enjoy summer and enjoy the upcoming Christmas. All the best.